In steady, level flight, the lift must equal the weight of the glider, or more precisely, the vertical component of lift must equal the weight. So for each airspeed, there is a corresponding angle of attack. I've plotted this relationship for a hypothetical glider here. This graph is only valid for this glider at a given weight. At high speeds, you can see the angle of attack will be very low. At low speeds, a greater and greater angle of attack is required to create the necessary lift. Unfortunately, an airfoil can only deflect the air so much before the air will no longer turn the corner around the top of the airfoil. At this point, the flow is said to separate, and the lift starts to decrease as the angle of attack continues to increase. At this point, we say the airfoil has stalled. The angle at which this occurs is called the critical angle of attack. This is an important concept to remember. It isn't the airspeed or lack thereof that causes the airfoil to stall, but it's only the angle of attack that matters. Now I'm going to show a video where tufts of yarn have been placed all over the wing of the glider. These will indicate when the airflow is attached because the tufts will be blowing straight back. As the wing stalls and the flow separates, you'll see the tufts start to flutter around and even blow backwards. At the start here, notice that all the tufts are blowing straight back, so the airflow is attached. At this point, you can see the tufts on the inboard part of the wing near the fuselage start to flutter, indicating that the airflow is starting to separate. The area of separation quickly moves outboard and forward on the wing. Now let's look at that again, but from a little bit closer in. Again, notice how the separation starts at the trailing edge of the root in this red area, then moves forward. Also notice that as soon as the angle of attack is decreased by lowering the nose of the glider, the flow immediately reattaches. As we watch this one more time, look at the tuft on the side of the fuselage. This will give you a rough idea of the angle of attack of the glider. As we start out, the tuft is almost horizontal. As more and more of the wing stalls, the glider starts to drop, so the relative wind is coming more and more from below the glider. So even though the pitch attitude during this time isn't changing much, the angle of attack is continuing to increase rapidly.